In this video, we shall look at magnetic field and magnetic forces. At the end of this class, you will know magnetic materials, magnetic poles, law of magnetism, magnetic field, magnetic flux density, magnetization and demagnetization, temporary and permanent magnet, and earth magnetic field and its importance. There are some materials in nature that has ability of attracting other materials to themselves. We call such material a magnet. So magnets are substances that has the property of attracting other substances to themselves. The force exerted by a magnet in attracting other material to itself is called magnetism. And this force can be an attractive or a repulsive force. It's not every material that can be attracted by a magnet. Those ones that are attracted by a magnet, we call them magnetic material. While those that are not attracted, we call them non-magnetic materials. Example of magnetic materials are iron, cobalt, nickel, steel, etc. While those that are not attracted that we call non-magnetic material, example are wood, glass, copper, rubber, and many others. When a bar magnet is suspended with a thread, it normally points in a north-south direction, showing that we have two poles, the south pole and the north pole. In the course of this video, we will explain why a bar magnet suspended normally points in the north-south direction. Magnetic poles are regions where magnetic force are concentrated or greatest. Looking at this bar magnet, a rectangular bar magnet, we have the south pole, we have the north pole. So the magnetic strength is concentrated majorly in the north and in the south poles. The force exerted by a magnet, the repulsive or the attractive force, depend on the pole strength, the distance between them. If you have two poles of the same poles or of different poles, depend on the distance between them. We shall look at it as we make progress, and also the medium in which they are placed. This was first observed by Coulomb and is called Coulomb's law of magnetism. What does the law state? That if you have two bar magnets of pole M1 and M2 separated by a distance r, that the force of attraction between them is given mathematically, that F is directly proportional to the product of the two poles, but inversely proportional to the square of the distance between them. If we remove the constant of proportionality, introduce a constant A, we have equation 2. And if our constant is given by equation 3, by substituting, we have equation 4. So equation 4 is used to compute the force of attraction between two poles, magnetic poles of pole strength M1 and M2, separated by the distance r. Then the constant here, mu naught, is the permeability of free space, mu r is the relative permeability of the medium. So these are constant. If we know the pole strength and we know the distance of separation, we'll be able to calculate the force of attraction if the poles are of different types, or the force of repulsion if they are of the same poles between them. So we use equation 4. Okay, let's look at an example. We have equation here. We have to calculate the force between them, between the two poles. We have the following parameter. The distance between the two poles is given as 25 cm, which we convert to SI unit to be 0.25 meter. Using our earlier expression to compute the force of attraction, by substituting and simplifying, we have the force between them, the two poles, to be 6.0 times 10 to power minus 3 Newton. Let's look at types of bar magnet. We have different types of bar magnet depending on the application. We have the cylindrical bar magnet, the horseshoe magnet, the ring magnet, the rectangular. So all this type is based on the application. Let's look at uses of bar magnet. Bar magnet has different application. It is used in electronic devices such as telephone, radio, and television set. Also, we find the application of bar magnet in medical procedures. In industry, bar magnet is equally used. Bar magnet is also used in the laboratory for magnetic experiments. Let's look at laws of magnetism. Experiments have shown that if you have two bar magnets of the same pole, it repel. This north-north, you see the repulsion there. This south-south pole bringing together, see the repulsion as well. While if you have bar magnet of different poles, if you bring together, you see the attraction. So the law of magnetism states that like poles repel each other, while unlike poles attract each other. Let's look at magnetic field. It is defined as the space or region around a magnet or a current carrying conductor where magnetic force are felt or experienced. And such a space contains magnetic line of force. Magnetic line of force, we cannot see them with our naked eyes, but it has some properties. They are parallel, they are radially curved outward, and they repel each other, creating neutral point, which are points of zero magnetic flux. This is a bar magnet. This is the magnetic field created by this bar magnet, represented with magnetic lines of force. The arrow shows the direction. Magnetic line of force normally originates from the North Pole down and enters the South Pole. And like we said, the magnetic force is concentrated at the pole. As we can see here, these are two bar magnets adjacent to each other. North-north, they repel based on law of magnetism. North-south, you see the attraction based on the law of magnetism. So these are magnetic fields created by two bar magnets adjacent to each other. These are magnetic line of force. Let's look at magnetic flux. It refers to number of magnetic line of force in a given magnetic field. And the density of the line indicates the magnitude of the magnetic field. This is a bar magnet. These are magnetic line of force. So the number of this line give us what we call magnetic flux. Like we earlier said, the magnetic line of force cannot be seen with our naked eyes. However, it can be demonstrated using a plotting compass and even iron filing. Iron filing are small thin pieces of iron. If you go to electric welder or those dealing with iron, while they are cutting metal, the pieces, the spark that do come out of it, they are the iron filing when they settle and cool down. It's nothing but pieces of iron. So if you have your bar magnet and you put the iron filing on top of a piece of paper, bringing your bar magnet beneath it, you have a pattern like this, showing the magnetic field. So this is what we use to show magnetic line of force, the magnetic field, since it cannot be viewed with the naked eye. And magnetic flux is measured in unit called Weber. Let's look at magnetic flux density. It is the magnetic flux per unit area, and it is measured in Weber per square meter or Tesla. So equation 5 gives us expression for magnetic flux density. So if we know the magnetic flux of a given bar magnet, we know the cross-sectional area of the bar magnet, we can compute the magnetic flux density. Let's look at an example. This equation, we are to calculate the magnetic flux density. In the equation, we know the magnetic flux, we know the area. The magnetic flux density is what we are to calculate. Using the expression and substituting, we have our magnetic flux density to be 154 Tesla. Next, let's look at magnetization and demagnetization. Magnetization is the process in which magnetic materials attain magnetism. For instance, this is a bar magnet. This is an iron bar, a magnetic material. As we can see, it is attracted by a bar magnet, and the process is called magnetization. And this iron bar is acting now like a magnet, thereby attracting the pieces of a paper clip, which is an iron, a magnetic material. So the process of making this iron bar to attain magnetism is called magnetization. Then there are the process of making a magnetic material. The process of magnetization are by single touch method, by double touch method or double stroke, and by electrical method. Let's look at each of them. The single touch method, if you carry a magnetic material, for instance T-bar, and you have your permanent bar magnet, if you strike it after some time, the steel bar will acquire magnetism and it will act like a magnet, thereby attracting other magnetic material to itself. Let's look at the divided touch or the double stroke method is similar to the single touch. Here, a magnetic material steel bar is being stroked by two permanent bar magnets for some time, and in the process, it will acquire magnetism, the process which we call magnetization. Then the third method is electrical method. Here, you put your magnetic material steel bar in a solenoid carrying DC current. If you allow it in the solenoid after some time, you discover that it will acquire magnetism and it will act like a magnet. Okay, let's look at the magnetization. Is the opposite of magnetization. Is the process of removing magnetism from a magnet. Like we demonstrated earlier, a iron bar, being a magnetic material, was attracted to a bar magnet, and it acted like a magnet, thereby attracting a piece of what? Another magnetic material. But the moment the iron bar is lifted up, the bar magnet is lifted up, the iron bar loses its magnetism and the magnetic material will follow. So the process whereby the iron bar losing its magnetism as a result of what? The bar magnet being lifted up, it is called demagnetization. Different ways of demagnetization are by striking, by exposing the magnet to alternating current, and by hitting the magnet. So if you have a magnet, hit it, for instance, with a hammer for some time, you discover that it will lose that ability. It will be demagnetized and it will become like a magnetic material. Another method is by electrical method. If we put a bar magnet in the solenoid, this time around, if alternating current is supplied to it, allow it for some time and remove it in east-west direction, you discover that the magnet will lose that ability. Process called demagnetization. So electrical method is another method of what? Demagnetization. Let's look at temporary magnet. A temporary magnet is one that attains its magnetism only in the magnetic field produced by a magnet. A temporary magnet is produced from soft magnetic material, which is a material that are easy to magnetize but does not retain its magnetism. Example of soft magnetic material is iron. So temporary magnet can easily be magnetized but loses its magnetism easily, so it can easily be demagnetized as well. A permanent magnet is one that retains its magnetic property for a long period of time, and it is produced from a hard magnetic material, which is difficult to magnetize, but retain its magnetism for a long period of time. Example of hard magnetic material is steel. So a permanent magnet, we can say they are magnets that cannot be magnetized easily, but retain its magnetic property for a long period of time. So this, we have shown this before. A bar magnet, an iron bar, acting as a magnet, attracting other magnetic material to itself. The moment the bar magnet is lifted up, we discover that the iron bar loses its ability. So iron bar here is a temporary magnet, can easily be magnetized and can also easily be demagnetized. Let's look at uses of temporary and permanent magnet. Permanent magnet is used in moving coil ammeter, magnetic door casket, electric motor, moving coil, loudspeaker. Temporary magnet also has its own uses. It is used in scrapyard electromagnet. It is used in circuit breaker. It is also used in electric bell. So both temporary and permanent magnet have their various uses. Let's look at Earth magnetic field. Earth magnetic field is produced mainly within the Earth interior and form a protecting shield around the planet called magnetosphere. And the Earth magnetic field is generated by a geodynamo. This is Earth magnetic field. This is planet Earth showing the Earth magnetic field. It is assumed that the Earth magnetic field is like a bar magnet at the center of it with a north and a south pole. I earlier told us that when a bar magnet is suspended freely, it always points in a south-north direction. And I told us that I will explain the reason later. The reason is due to the Earth magnetic field. Like we saw earlier from the law of magnetism that like pole repel. So when you suspend the bar magnet, the south pole here will attract the north pole from the suspended bar magnet. So because of the attraction, in line with law of magnetism, whenever a bar magnet is suspended freely, normally point in a south-north direction due to what? The effect of the Earth magnetic field. The Earth magnetic field is very important, very essential for life on Earth. It protects the near-Earth environment from dangerous radiation and high-energy plasma from the sun by partially blocking them out. It also prevents the Earth atmosphere from being blown away by the solar wind from the sun. This is the sun. This is our planet Earth. The sun releases solar flare, solar wind, and all towards the direction of the Earth. We can see how the Earth magnetic field is acting as a shield, thereby deflecting the solar wind, the solar flare, the coronal mass ejection, and other particles released from the sun towards the Earth. You see how it's deflecting it, the Earth magnetic field acting as a shield. So let's look at this. This is how the Earth magnetic field acts to protect the Earth atmosphere. Look at it again. Whenever the sun releases particles, it moves towards the Earth magnetic field shield it by deflecting the particles and other things released from the sun. Look at it again. So thank you very much for listening. Please subscribe to my channel for more videos. Like and share this video. Thank you. Bye for now.